The analog input modules are also under the AI300 subgroup. As you can see, just as we had previously, each of the modules in here is represented by a specific code that shows us their main characteristic. For example, in the module we have here, AI8 shows us that this is an analog input module with 8 inputs. But what does this 12-bit show us? If you answered that it represents the accuracy or the resolution of this module, you were right. What is resolution, though? In simple words, resolution of an analog module refers to the smallest changes in the input signal that are recognizable by the module. In other words, resolution tells us how sensitive our module is to changes in the input signal. As an example, if we have a small change in our input signal, it's possible that a 12-bit analog input module won't be able to recognize this change. However, a 16-bit module can recognize this change quite easily. Therefore, the higher the resolution of a module, the better the module's ability to recognize small changes in the input signal. The analog signals that connect to the AI module can be of different types. For instance, they can be of voltage type, of current type, resistance type, or temperature type. Some of the analog modules in here have the ability to receive all variants of the common signals to their input. This means that it makes no difference to the modules whether the analog input signal type is voltage, current, resistance, or temperature. Regardless of the situation, we can connect these signals to these modules. However, there is a series of other analog modules that can receive only one or two specific types of analog signals to the input. For example, this module here that has RTD in its code can only receive signals from RTD sensors, which is a resistance type. The other one has the letters TC in its code, so it can only be connected to a thermocouple whose signal is a temperature type. So, the point to note is that when we choose an analog input module for our PLC, we first need to ascertain the type of our input signal, which means that we need to check to see if the input signal type is voltage, current, resistance, or temperature, and then, based on what we need, select an analog input module capable of receiving that specific type of signal. Having clarified the type of signal that modules containing the letters RTD or TC in their codes can receive, how can we identify the type of signals that can be received by modules that do not have a specific sign in their codes? The easiest way to do this is to study the manual of those modules. For instance, the analog module here in the enclosure is a module with 8 analog inputs and a 12-bit resolution. Its order number is 6ES7-331-7KF02-0AB0. Now, if we want to establish the type of signals this module can receive to its input, we open up the S7300 module data manual and hit Ctrl F here so that the Find box opens up. Then we enter the middle part of the order number of our module, which is 7KF02. And hit Enter on the keyboard a few times until we get to the explanation page. We see that under measurement type here, it tells us that this module can receive all types of signals to its input, such as voltage, current, resistance, and temperature. So we don't have any limitations in regards to the input signal of this module. We can connect all types of analog input signals to it. Now, what if we don't have access to this manual? If we place our module based on its order number on the rack in the hardware configuration and then double-click on the module, a properties window related to that module opens up. Here, in the input header, if we click in the box in the measuring types section, we can read that this module can support voltage, current, resistance, and temperature signals, which means that it can receive these types of signals to its input. So, in order to identify the types of signals our analog input module can receive to its input, we have two options: check in its manual, or place the module on the rack in the hardware and double-click on it to open the Properties window. This concludes selecting and configuring the analog input module in the hardware. Up until now, we've entered all of our desired modules, and we've completed the configuration. In the next lesson, we explain how to use the PLC simulator and then return here to learn how to download our configuration to the CPU.